All right, let's get to it. We're going to figure out a way to make our robot, we're not only sending commands to it, it's sending sensor data back. And you can use this to build other things. Say you want a remote air quality sensor in your house. You could have it broadcast to your computer and give you data using the same kind of thing, or all kinds of stuff. Anyway, anytime you want something to send you back data, here's a good way. First of all, we don't want it to just like shoot data at us constantly, so we're just going to get it to do it every so often. So to do that, we need it to wait for a certain amount of time to pass before it updates its previous value. So that's what we're doing now. Same kind of thing we've done previously with time delays in previous projects. So we're going to need to make an unsigned long. Remember, unsigned means it's only positive, it can't be negative. That lets you hold double as big numbers. And long is just a big integer. So it's got to be a positive 0 or positive number that can be really big. And we'll call this one previous time and start it off at 0. Oop. And that's great. So done there. We can also do an unsigned long called current time, initialize it to 0. You can handle that. We can also do a long or unsigned long called interval. You could probably use an int too, whatever. I'll do an unsigned long for fun. And this is how long you want to wait for. So if you want it to update its values every half second, which is a reasonable amount, if it's not often enough, you can change it and make it smaller. If it's too frequent, make it longer. But if we do 500, we're going to be using the millis command, millis. So that gives us number of milliseconds since the robot was turned on or reset. So 500 is half a second. So it should be good. All right, so we got a fake sonar method just so it runs. And let's give it a shot. So we want to set the current time to how many milliseconds it's been since the Arduino was turned on or reset. So we can just, anytime we want to set something, we just say what we want to set and make it equal to milliseconds. If only we had a command which gives us milliseconds since it was last turned on or reset. And if you forget, millis, that's it. That's seriously all you got to do. I'll delete it for those people not really watching the video. If it's been longer than interval milliseconds since we last transmitted, this one's a little trickier. This one I'll actually show you and then delete for those people just skimming the video. So this if is important. So we want to check to see if it's been the difference between the current time and the previous time is greater than our interval. So if we do current time minus previous time, if that amount, if current time is more than 500 milliseconds bigger than our previous time, which was set last time it sent a value, then we want to send another one. And so then we just print it to the computer, which is just a serial.println. And we want to print the sonar value. So currently our sonar just returns 7, so we could just print sonar. Which is kind of funny. You wouldn't think you'd be able to just print it, but this is equal to an integer, and you can just print out an integer. So works out perfect. That's the easiest way to do it. And then once we've sent something, we want to reset our counter. So we're going to set previous time to the current time. So it'll take another 500 milliseconds till current time is more than 500 milliseconds greater than previous time. So this is us resetting our counter. We could also make previous time equal to millis at this point. But that's kind of what you want. And then once you've got this, we got to amalgamate it into the other project. So I just have it all done already. and it's not a big difference. So this one, we're pretty much just copying that into here. I've got a different sonar method than you do. Mine just updates distance. So we've got this variable called distance here. That's global scope, so it just doesn't go away. So sonar makes it equal to the current distance from the nearest object. And then I just print that value. And this is only if the current time is 200 milliseconds greater than my previous time. So I've got it updating 5 times a second, every 0.2 seconds instead of 0.5. Notice I've got if serial.available is greater than 0. So if there's a command to read, it'll do that. That's top priority. So if it's been given a command, it'll deal with that command. Notice everything is inside that if statement. Oops, sorry. Everything's inside that if statement. And then if there's nothing available, no commands it needs to follow, it'll check to see if it's been long enough so that it should send another update to how far away it is from something. And then it'll figure out how far it is from the nearest object, send that info back, and then reset the counter so it's ready to wait another 200 milliseconds or 0.2 seconds. And then this all-important delay 1, so it works for some reason, just so it's not constantly bombarding the serial. And that is all. Once you got that, you've got a fully functional robot that you can command from your computer. It'll send data back. You should be able to fully control it and receive data back using the serial monitor now. In the next video, you can use my Arduino command, so you can make it a bit more smooth. But yeah, you're essentially done. Congratulations. Thanks for watching.